Hello, I'm Talon Marquardt, and I will be explaining my research project for the University of Wyoming Modern Robots class. The goal of the evolving robots was to discover faster learning and more robust behaviors. Just as animals start as babies and develop bodies and minds over time, I'd hoped to replicate this process in my robots. Children are also much more impressionable when younger. This motivated me to include simulated annealing into my project. Due to time constraints, it was implemented in a very rudimentary way. For the experiment, I have 5 stages of robots. It begins with a 4-legged table robot, 4-legged with lengthened body, 6-legged, 6-legged with lengthened body, and 8-legged. The robot evolves over 500 iterations of simple hill climbing, while passing on the neural network at each stage. This is done again, but with simulated annealing, which will be explained more later. I also have a control group for comparison. The control uses standard hill climbing for each stage of growth. Instead of passing on the network, a new fully connected network is created and randomized. The 4-legged robot goes for 500 runs, the 4-legged long for 1,000, 6 for 1,500, 6 long for 2,000, and 8 for 2,500. This gives each robot the same amount of evolutionary time as in the experimental set. When passing the neural network, the best network from the past 500 are written to a file. The initial robot of the next stage reads in the network. For the lengthened body, this exact network is used. For when legs are added, new neurons are added for the input and output. The new input neurons are given full connections to each output with weights set to 0. Each old input neuron is connected to each new output neuron, again with weights 0. The hope is by starting at 0, the robot may discover how to integrate the new legs into its already optimized gait. To further the idea of discovering the best way to adapt to the changing body, I implemented a pseudo-simulated annealing. I hoped to allow more flexibility and adaptation for the robots. I want to be able to explore more behaviors and network configurations. The annealing needs lots of refinement, which is why I say pseudo-simulated annealing. For now, mutation rates change every 25 iterations of hill climbing, up to the 400th iteration. The mutation rate for new connections or new neurons is set to 50% and goes down to 2%. The rate for changing the value of a neuron or the weight of a connection starts at 90% and goes down to 5%. All step sizes for mutation rates are of equal amounts. Here we can see the various networks for the growing robot, as well as plots of their general fitness, which is simply the distance they walked from the starting point. The network plots are confusing because for more than 4 legs, input and output neurons are lumped in the middle as well as the outside. Despite this, some transference can be seen in the networks, though the starting and end fitness don't seem to be getting any better. The annealing certainly grows the networks, though the learning rate doesn't seem to be improved. Again, the transfer of knowledge doesn't appear overly helpful. Here we can see the control group doesn't seem significantly different from the experimental. Again, annealing helps grow large networks, but significantly different fitnesses are rare, and more of the data looks similar to what we have seen in other experiments. Looking at all the plots together and the different tests put side by side, we see that there is a large amount of variation in all of the data. All of the fitnesses are fairly similar over all the tests as well. The more complex robots seem to be doing worse than the simpler designs. We can observe the more complex robots doing worse in these videos. From the plots, we saw that behaviors transferred very poorly, and that each robot had to relearn how to walk. The behaviors are still interesting, and good approaches are obvious. It can be seen why the large robot does poorly. The control group also looks fairly similar. From all this, I've realized that the networks evolved do not transfer well. Also, in this context, the large robots become too complex and don't walk with coordination or speed. This could also be because of problems in the code and experimental setup. In the future, I would like to fix and refine my code and experimental setups. I would like to explore other values for the connections added between stages, and I would also like to collect much more data and clean it up. Finally, it would have been nice to do statistical analysis to discover what was truly good and bad. Thank you for watching.